Let's start with Mercury, the smallest planet and the closest to the Sun, and it immediately does something unexpected. Mercury is shrinking, not metaphorically, literally contracting. As its iron core slowly cools, the entire planet is pulling inward, and that process has carved massive cliff systems called Lobate Scarps across its surface. NASA's Messenger spacecraft mapped nearly 6,000 of these across the planet. One of them, Enterprise Rupes, stretches about 1,000 kilometers long, with over 3 kilometers of vertical relief. To put that in perspective, the San Andreas Fault looks small next to it. Current estimates suggest Mercury has shrunk somewhere between 2 and 4 kilometers in diameter total, and for reasons no model has fully explained, the largest of these cliffs are 3 times more common in the southern hemisphere than the north. So Mercury is already weird, but Venus, the next one out, might be weirder. Venus is almost exactly the same size as Earth, which is why people used to call it Earth's twin. But it spins so slowly that a single day on Venus is longer than its entire year. And here's the part that almost never gets mentioned, that spin rate is actually changing. Radar measurements show Venus's rotation period has shifted by several minutes over just a few decades, likely because its thick carbon dioxide atmosphere is dragging on the planet like a brake. A planet's spin drifting on a human timescale, that's almost unheard of, and it barely shows up outside of specialist research papers. Now we get to Earth, and you'd think this one is the safe, boring entry. But the Moon is hiding a secret most people don't know. The leading model for how the Moon formed involves a Mars-sized body called Theia slamming into proto-Earth about 4.5 billion years ago and blasting debris into orbit. Most people have heard that part. What most people haven't heard is a variant of that model proposed by researchers Jutsi and Asfaug, which suggests the impact actually produced 2 moons. A second, smaller companion formed from the same debris cloud and eventually drifted into the near side of the Moon in a slow collision, which would explain something that's always been a puzzle. The Moon's near-side crust is noticeably thinner than the far side. 2 moons became one, and we're living in the aftermath. That brings us to Mars, and this is where the sequence starts to crack open. Because Mars should be bigger. Way bigger. It sits in a zone where a full-sized planet should have formed, and instead it's a runt, roughly 1/10 the mass of Earth. For a long time, nobody had a good answer for why. Then came the grand Tack hypothesis. It proposes that Jupiter formed at a distance of about 3.5 AU from the Sun, then migrated inward all the way to 1.5 AU, almost exactly where Mars sits today, before reversing course due to capturing Saturn in an orbital resonance, and eventually settling near its current orbit at 5.2 AU. According to this hypothesis, the planetesimal disk was truncated at 1.0 AU by Jupiter's migration, directly limiting the material available to form Mars. Jupiter swept through, ate the raw material Mars needed to grow, and then pulled back out. Mars never had a chance. The planets aren't in their birth order. Jupiter used to sit where Mars is now. And I want to hold that thought for a second because it connects to something much bigger that I'll come back to at the end of this video. The sequence we see today, the one you memorized, may not be the sequence these planets have always been in. Next is the asteroid belt, and this is where an old mathematical trick becomes genuinely strange. In 1772, a German astronomer named Johann Bode formalized a simple number pattern, now called the Titius-Bode relation, that described the spacing of the planets from Mercury through Saturn. The formula was almost embarrassingly simple, just a doubling sequence, but it matched the known planets so well that astronomers used it to predict where undiscovered planets should be. It pointed to a gap at 2.8 AU, which is exactly where Ceres was found in the asteroid belt. It predicted Uranus before Uranus was discovered. The problem is, it completely breaks down at Neptune, and to this day, nobody has produced a physical reason for why it worked as well as it did. It might be a coincidence. It might be something real. We genuinely don't know. Now Jupiter, the largest planet in the solar system. A ball of hydrogen and helium so massive it contains more than twice the mass of every other planet combined. Jupiter is the gravitational anchor of the whole system. But the detail most videos skip is what Jupiter's presence actually cost us, and what it saved us from. Its gravity has been flinging comets and asteroids out of the inner solar system for billions of years, acting like a shield. At the same time, it's the reason Mars is tiny. Jupiter gives and takes simultaneously, and the inner solar system is shaped entirely around it. Saturn is next, and if you've heard anything about Saturn before, you've probably heard about the rings. But the rings are almost the distraction here. Look at the North Pole. The giant planets did not always occupy their current orbital positions. But Saturn's North Pole is doing something that has nothing to do with migration. There's a hexagonal jet stream up there, a six-sided storm roughly 30,000 kilometers across, wide enough to fit 4 Earths inside. Cassini imaged it in stable detail for over a decade. It's been there since at least Voyager flew by in 1981, and nobody has confirmed why it locks into 6 sides instead of any other shape. Nature almost never produces straight lines in fluid dynamics. Circles and spirals, yes. A perfect hexagon sitting there for at least 45 years. That's a different category of strange. Uranus is where things get genuinely disorienting. It rotates on its side, tilted about 98 degrees, so its poles point roughly toward the Sun rather than its equator. The standard explanation is that something hit it early on and knocked it sideways. But here's the detail most videos skip completely. Its rings and moons orbit in that same tilted plane. They didn't get dragged along after the fact. They formed there. Which means the collision happened before the moons formed, not after, and the entire system was essentially rebuilt on a vertical axis. Uranus didn't just get knocked over. It started over, and now Neptune, the last planet in the lineup, and the one that pays off the thread I've been pulling on this whole video. Neptune's largest moon is Triton, and Triton orbits backward. Every other large moon in the solar system orbits in the same direction as its planets spin. Triton goes the opposite way, which is a dead giveaway that it didn't form here. Triton is almost certainly a captured Kuiper Belt object, a chemical cousin of Pluto that wandered too close and got locked into Neptune's gravity. It's now slowly spiraling inward, and in a few 100 million years, Neptune's gravity will tear it apart and scatter the debris into a ring system. We're watching a moon die in slow motion. But the real payoff is this. How did Neptune end up out here in the first place? The NICE model, published in a landmark series of papers in 2005, proposes that the solar system's giant planets, Jupiter, Saturn, Uranus, and Neptune, did not always occupy their current orbital positions and instead migrated to them over time through gravitational interactions with the disk of small bodies that surrounded them. The model proposed that the formation and migration of the giant planets to their current locations, including the swapping of Uranus and Neptune's positions, may have been the mechanism that disrupted the asteroid belt and caused a massive influx of impacts on the inner solar system. This powerful, repeated gravitational interaction rapidly increased the planet's orbital eccentricities, throwing the entire outer system into chaos. Uranus and Neptune were flung violently outward into the dense planetesimal disk, scattering billions of icy bodies. So here's what that means. The order we memorized, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, is not ancient. It's not original. Jupiter used to sit where Mars is. Uranus and Neptune may have swapped places. The arrangement we see today could be less than 500 million years into its current configuration. The sequence isn't a blueprint. It's a snapshot of something still settling. And that's the thing that changes when you watch a video like this. You start with 8 planets in a line, and you end with a solar system that has been crashing, migrating, shrinking, capturing, and rebuilding itself the entire time. The order is the story. You just have to know what to look for. If you want to go deeper on any of these, Saturn's rings, the moon-forming impact, or what the Kuiper Belt actually is, I've got videos on the way. The Saturn one in particular will genuinely change how you see that planet. Drop a comment telling me which planet surprised you most in this one, because based on what I've seen, people are split almost evenly between Mars and Neptune, and I want to know where you land. And if this is the kind of content you want more of, subscribing is the best way to make sure you don't miss the next one.